Okay, I'm doing some more tests with the rotovertor. I have the generator plates off, 8 magnets in each. I have the stator plate with 8 coils off. So we're looking at it spinning free. Right now, it's drawing 170 milliamps and 120 volts, 60 hertz. And this is with no run cap hooked up. No run cap. Now I connect the run cap. And it goes down to 60 milliamps. Usually I can get that down to 30 milliamps by adjusting the bearing fore and aft tightness, but this is what it is right now. I have this is measuring voltage. It's across the run cap, and it's 171 volts. Now, I'm going to measure voltage. I'm going to measure current that's circulating through the run cap phase. I have my meter in 20 amps AC. And I will disconnect one of the lines going to the run cap and put the ammeter in series. So right now the run cap's disconnected, so it's drawing 160 milliamps. Now I'm connecting the run cap and looking at what amperage is in AC that's circulating. So it's 270 milliamps. So this is called VARS, V-A-R-S, volt amps reactive. And that's what's circulating within the run cap phase. It's 270 milliamps and 171 volts. Okay, while it is drawing, and this is watts, input, 60 milliamps and 120 volts. Now, when you change the run cap, things are going to be different. So let's do that. 1 minute. Okay, interesting. I wasn't expecting this. I just changed it to a 2 and a 1 for 3. These are in parallel for 3 UF. So I just brought the run cap from 4 UF down to 3 UF. Now the draw went down to 40 milliamps, which is good. And it used to be 60 milliamps, so it's drawing less. Now with a 3 instead of a 4 UF run cap, and we're making 148 volts across the run cap phase. So isn't that interesting? Now I'm going to measure the current circulating. So 1 minute. Okie dokie. Now we only have 150 to 160 milliamps circulating in the run cap phase. Remember, it used to be, I think, 280. So a lot less current is circulating in there. And but we dropped the draw down to 40 milliamps. Now I'm seeing 52 on the meter here. I don't know what that's about. taking the voltmeter off. Oh, it was just barely touching on one side. Okay, 1 minute. Okay, I got things stable now. This is a 3 UF run cap, 160 milliamps circulating in the run cap phase, and there's 147 volts in the run cap phase. So that's interesting in that the draw went down to 40 milliamps. Let's see what happens when we go with a 2. We'll take, we had a 4 UF, then we went to a 3 UF, now we'll go to a 2 UF. And all I got to do is take off a 1 UF cap, take that off and just go with a 2 only. Okay, watch this. I'm going to go from 3 UF to 2 UF. And at 3 UF it's 160 milliamps. I'll take this off. Look at that, it goes down to 70 milliamps circulating. Remember with a 4 UF we had 280 milliamps circulating. And with a 2 UF cap, there's only 120 volts across the run cap phase, and look how much the draw went up. It was just at 40 milliamps, it went to 90 milliamps. So you don't want a 2 UF run cap with this, what's going on now. That's for sure. Now I'm going to hook up this and go back to 3. And now we're up to 160 milliamps circulating. We're down to input of 40 milliamps, and we're up to 148 volts. So we've done a 2, 3, and a 4, so let's do a 5, and we'll call it good after that. This is what you do with a run cap on a rotoverter. You go one interval of 1 UF interval at a time. Increment. Okay, just a minute. Okay. Whoa. Just a minute. Okay, now I have 5 UF. I have a 4 plus a 1. The 5 UF for the run cap. And look what I get. 360 milliamps circulating. 182 volts. Used to be 171 at the highest. But look at the draw. It's up to 130 milliamps. From the lowest of 40 milliamps. So that's a 5 UF. Okay, this is so much fun. Let's do one more at 6 UF and see what we get for amps circulating and voltage across the run cap and what the draw is. So we're going to go with a 6 UF now. Wow. Just 6 UF instead of 5 UF. Now we have 450 milliamps circulating and 190 volts in that run cap phase, while the draw has now gone up to 210 milliamps. So maybe if what you want out of this thing is a lot of current and voltage in that run cap phase, also called the rotary transformer phase, and you aren't so concerned about the draw, you might want to use a 6 UF run cap. So one more. I'm going to go up to 7, see what happens. Okay, 7 UF run cap. A 4 and a 2 and a 1 for 7. And look at, we got how much current is circulating. 540 milliamps circulating of current. Voltage is 196 across the run cap, while the draw, in consequence, has gone up to 310 milliamps. So that's like 36 watts input right now. I wonder what the shaft is like. Definitely not going to be able to stop this by hand. And the draw, okay, here's no shaft torque. I'm pushing pretty hard on this. Like I said, there's no way I can stop this by hand. It doesn't go up too much comparatively, that it's 300 milliamps. And what do we got? Without anything on the shaft, 196. Now I'm going to grab the shaft with my fingers, and it goes down. Also, the amperage circulating goes down. So, all very interesting, if you're interested in stuff like this. So, I guess that's it for now. Thanks for watching.